Good morning to all of you. And this morning we are going to solve some numericals on bivariate, bivariate frequency. Now, bivariate, I told you, is a frequency table where two variables have been measured in the same set of items through a cross classification, and this is known as bivariate frequency distribution. So the question reads, the data given below relates to the height and weights of 20 persons. You are required to form a two-way frequency table with class intervals of 62 to 64 inches, 64 to 66 inches, and so on, and 115 to 125 pounds, and 125 to 135 pounds, and so on. So you see, children, we have been given two variables, height and weight. How do we do it? Like this. First of all, we will write bivariate frequency distribution as the heading. Then, since we have two variables, height and weight, we will take height in, and then weight. This will be in inches. Okay. Weight in pounds, lbs. Okay. What is the height he says to take from? 62 to 64. 62 to 64. 64 to 66. 66 to 68. 68 to 70. What is the maximum value there? We can go up to 72 because 70 is there. 71 also is there. So 72. Okay. And the weights, he says, start from 115 to 125. 115 to 125. 125 to 135. 135 to 145. 145 to 155. What is the maximum weight we have? If you see in the column, we have up to 163 I can spot. So we'll have to go much beyond that. So 155 to 165 and 165 to 175. So here we have the weights, here we have the height, and this I will wipe out. Statistics. Bivariate frequency comes on top over here. Okay, this is the bivariate frequency. The height is given in inches. Bivariate frequency distribution. Okay. Now, what do you see over here? How do we plot these? Just a minute. Today I am allowing some people who are late, but I shall not be doing it on a regular basis. You have a class at 8:30, you will be on time. Excuse me. Now, how do we plot it? Simple as ever. You will look at the first entry, 170 weight, height 70. So 170 comes here and the height comes to 70. So from here, put one frequency bar, one tally bar. 170, 70. Then second is 135, 65. 135 is here, 65 will be here. So one tally bar. Next, 136, 65. 136 is here, 65 here. Then 137, 64. 137 will come here, 64. 64 will come here. Then 148, 69. 148 will lie here, 69. 69 will come here. One tally bar. How much was that? 148, 69. Okay. Then 124, 63. 124, 63 will be here. Then 117, 65. 117, 65 will be here. 128, 70. 128 will be here, 70 will be here. Then 143, 71. 143, 71 will be here. Okay. 129, 62. 129, 62. Okay. We'll have a total here and we have a total here. Okay. Then 143, 71. 143, 71 is here. 129, 62. 129, 62. 163, 70. 163 comes here. 70 comes here. 139, 67. 139 will come here. 67. 67 will come here. 122, 63. 122, 63 will come here. 134, 68. 134, 68 will come here. 140, 67. 140, 67 here. 132, 69. 132, 69 will come here. 120, 66. 120, 66. 148, 68. 148, 68. Then 129, 67. 129, 67 will come here. And 152, 67. 152, 67. Okay. 2, 4, 5, 8, 9, 10, 11, 12, 13, 14, okay. Kindly do this. First one will be 4, 5, 1, 2, then 6. This will come down. Then 3. Now, children, after you have plotted it like this, what you're going to do at the side, you will going to write the number of tally bars. This is 2. This 125 to 135 should be 1. This is 1. This dot, this is 3. Then this is 1. Then this is 1. Then this is 2. This is 168. Then this is 2. This is dash. This is 2 dash dash. Then this is a dash. This is 1. This is 1. Then this is a dash. This is 1. And this is 1. So in brackets, you are going to write the number of tally bars that are there in the class. Then what we are going to do is add them up horizontally and then vertically, and the total should be the same. 2, 3, 4. So this is 4 here. 1, 3, 4, 5. This is 5 over here. Then 3 and 2, 5 and 1, 6 over here. 2 and 1, 3. Then 1 and 1. Total up this way also. 2 and 1, 3. 3 and 1, 4. 1, 2. 4 and 1, 5. 2 and 2, 4. 1, 2, 3, 4. Now totaling it up, 5 and 4, 9, 15, 18, 19, 20. Total it this way, 3 and 4, 7, 12, 16 and 4, 20. So your total horizontally as well as vertically should be the same. When you add it this way, you should get the total 20. When you are adding it this way, your total should be 20. This is how you are to do a bivariate or a two-way frequency distribution. So when you are plotting, you have to plot both the variables and in a proper manner. Have you understood? When you are plotting it, when you are putting tally bars, be very careful. Now there are 20 items given to be plotted, and this is how you do it. For example, the first one, 170 and 70. So you will search for where 170 will go. 170 will go here. See my finger in this one. And where is 70 going to go? 70 here. So 170, 70. You put one tally bar like that. Then second one was 135, 65. 135, you are taking the exclusive. So 135, how much is that? 65. 65 will come here. So you put one tally bar. This is how you are going to put your tally bars. And then towards, after you put the tally bars, the number of tally bars that are there in brackets, you will write the number. Like here there are 2, here there is 1, 1, there is 3, 1, 2, 1, 1, and so on. After which you are to total them up like this: 2, 3, 4. Write the total there, 4. Then 1, 2, 4, 5, like that. Then 3, 2, 5, and 1, 6, 1 and 2, 3, 1, 1. Then you total this way also: 2 and 1, 3, 1 and 3, 4, 1, 2, 4, 5, 2 and 2, 4, 1, 2, 3, 4. Okay. Now when you total this way: 3 and 4, 7, 7 and 5, 12, 12 and 4, 16, 16 and 4, 20. When you total like this: 5 and 4, 9, 9 and 6, 15, and 3, 18, 19, 20. So the total this ways should be the same. Then only your bivariate or a two-way frequency distribution is correct. Is that okay? Is it okay? Any doubt? If it is okay, kindly can I get a thumbs up? Yeah? Good. Thank you. Yes. Now, children, I had also shared some more questions with you. Have you copied them down? Because that I will give for your practice. That I'm going to give for your practice. Now you're going to take your textbook and I'm going to do the question and answers from your textbook. Take your textbook to page number 37, statistics textbook. Okay. First question: which of the following alternatives is true? The class midpoint is equal to, kindly take the A option, the average of the upper class limit and the lower class limit. Second, the frequency distribution of two variables is known as, tick the bivariate. That is B option. Third, the statistical calculations in classified data are based on A option, the actual values of observations. And fourth, range is tick the A option, difference between the largest and the smallest observation. Now children, turn to page 33. All of you, please turn to page number 33. In 33, there is loss of information. Question comes: what is loss of information? If you see on page 33, underline this. That is from the 1, 2, 3, 4, 5, 6, 7th line on the third side, on the right hand side. Once the data are grouped into classes, an individual observation has no significance in further statistical calculations. Okay, then turn the page to page 34, fourth line. The use of class marks instead of the actual values of the observation in statistical methods involves considerable loss of information. Till there you will underline. Now understand what it says. What is loss of information? Now if you look at this table which we have just done, I will explain it through this table. There are two tally bars here under the group of 62 and 64. Now this tally bar is for which number? Do you remember? No. Do you remember? Which one is this tally bar? It could be 62, it could be 63. Which value? We don't know. So when we are plotting something in a frequency distribution, we are plotting it in the class interval. When we plot it in the class interval, the individual value we lose. Right or wrong? Now over here, let me pick up this. In the group 64 to 66, I have one tally bar, two tally bar, three tally bar. These three tally bars tell me what is the number I have plotted here. Is it 64? Is it 65? Which value? Is it told over here? No. We are just putting a tally bar. It could be that 64 was price written or 65 was price written. Yes or no? So in a loss of information, what happens when we are plotting in a class interval? The actual value we tend to lose. We only denote it by the class interval, that these three bars are in the class interval of 64 to 66 and having values anything between 135 to 145. What is the actual value? Do we know? No. By this, we don't know. But when we are plotting it, we are plotting it. So this is called loss of information. I hope I am clear. Okay? When we are plotting something, we are plotting them in their class intervals, whereby we are losing the actual value. We are losing the actual value. However, we know that, let's take this 135 and 145. We have three values of 64 to 66. Anything from 64, 65, anything from 135, 136, 137, 138, 139, 140, 141, 142, 143, 144 could be plotted here. But which is that value? Do you know? No. Only while you are plotting, you are aware that this has to go over there. So the actual value is lost. This is called loss of information in statistics. Is that clear, children? Yes? Okay. Now go back to the question number 2 of your book on page 38. Can there be an advantage in classifying things? Explain with an example from your daily life. Kindly write down the answer. Classification means, write down the answer. Classification means arrangement of items in a logical order. So that analysis of data or the purpose of study becomes simple and clear. In our daily life, we do arrange our routine work and any specific work in logical order to make it successful. For example, making a family budget by a parent, arranging school books according to class timetable, making a schedule to finish homework and specific schedules during school exams, etc. The list can go on and on, etc. Third question from your book. What is a variable? Distinguish between a discrete and a continuous variable. Third question. A variable is a unit which is capable of being measured in numerical terms. It changes its value over time. For example, income, profit, age, height, etc. Discrete variables are finite or exact numbers for example 10, 20, 30, etc. Whereas continuous variables is not exact and is measured in a specified range. Example 10 to 20, 20 to 30, 30 to 40, etc. I will stop till here because there's not much time left and it will suddenly shut down. So we will meet again with some more questions to be answered tomorrow. Till then, have a nice day and stay safe.